It was the 4th of June, 1942, and the sky above the Central Pacific was a chaotic nightmare of burning fuel, tracers, and shattered aluminum. 6 heavily armed American torpedo bombers, making their absolute first combat debut, were dropping down to the deck to assault the Japanese carrier fleet at the Battle of Midway. Within minutes, 5 of them were completely obliterated, blown out of the sky by a swarm of Japanese Zero fighters and a relentless wall of naval anti-aircraft fire. The single surviving aircraft, flown by Ensign Albert Ernest, was being systematically shredded by cannon fire. The hydraulic system was entirely shot out. The elevator control cables were hanging by a literal thread, severed by a 20mm shell. The tail gunner was dead, the belly gunner was unconscious, and the compass was smashed into useless glass and metal. By all known laws of aerodynamics and combat survivability, the massive, single-engine aircraft should have plummeted into the Pacific Ocean. Instead, it kept flying, with its bomb bay doors stuck open, acting as a massive drag brake, and the pilot fighting against a brutally heavy control stick using manual trim tabs just to keep the nose level. The crippled aircraft somehow limped back to Midway Island. When it crash-landed, the ground crews counted over 70 massive bullet and cannon holes in the airframe. Half of the control surfaces were simply gone, torn away by explosive shells, and yet the structural spine of the aircraft remained perfectly intact. This was the blood-soaked, terrifying combat debut of the Grumman TBF Avenger. It was a machine that earned a reputation not for elegant flight dynamics or blazing speed, but for a sheer, stubborn refusal to die. Before we dive deeper into the incredible engineering of this flying tank and how it completely changed the dynamic of naval warfare, if you are enjoying this deep dive into aviation history, take a second to subscribe to the channel. It helps us keep uncovering these incredible stories of military engineering and the crews who flew them. To understand why the TBF Avenger looked and flew like a heavily armored truck, you have to understand the desperate strategic crisis the United States Navy was facing in the late 1930s. Carrier aviation was evolving at a terrifying pace, and the premier torpedo bomber of the American fleet, the Douglas TBD Devastator, was rapidly becoming a death trap. When the Devastator first flew in 1935, it was a marvel of modern engineering, a sleek, all-metal monoplane that made biplanes look instantly obsolete. But by 1939, as the storm clouds of a global war gathered, the Devastator was dangerously slow, critically underarmed, and lacked the range required to fight across the vast, empty tyranny of the Pacific Ocean. The United States Navy recognized that a future Pacific War would be fought over thousands of miles of open water, requiring strikes against enemy fleets from far beyond the horizon. They issued a brutal, almost impossible demand to the aviation industry. They needed a new torpedo bomber that could carry a 2,000-pound payload, primarily the massive Mark 13 aerial torpedo, over a combat radius of 300 miles. It had to be fast enough to survive in skies contested by modern fighter aircraft, heavily armored enough to protect its 3-man crew, and most crucially, it had to fit on the tightly confined elevators and hangar decks of an aircraft carrier. Leroy Grumman, the brilliant engineer behind the Navy's rugged fighter aircraft, accepted this monumental challenge. His company, already famous for building structurally invincible aircraft, affectionately known as the Grumman Iron Works, set about designing a machine that would prioritize survival and payload delivery above all other aerodynamic concerns. The resulting aircraft, initially designated the TBF-1, was an absolute behemoth of a single-engine plane. When it rolled out of the factory, it was the heaviest single-engine aircraft produced by any nation in the world at that time. Fully loaded, it weighed over 18,000 pounds, which was significantly heavier than many twin-engine medium bombers operating in the European theater. To haul this immense weight off a short carrier deck, Grumman engineers selected the Wright R2 600 twin cyclone radial engine. This 14-cylinder air-cooled monster generated an astonishing 1,700 horsepower. It was a brilliant piece of propulsion engineering, delivering massive low-end torque to pull the heavy airframe into the sky, but it was incredibly thirsty, demanding massive internal fuel tanks that further increased the weight of the aircraft. But raw power was only half the equation. The real engineering genius of the Avenger was hidden in its geometry. Because the Navy demanded an aircraft that could fit in high density on a carrier deck, Leroy Grumman had to invent a completely new way to fold the wings. Legend has it that Grumman figured out the geometry by sticking paper clips into a rubber eraser, and twisting them around until he found the perfect angle. The result was the famous Sto-Wing system. Unlike older aircraft that simply hinged their wings straight upward, exposing their fragile undersides to high winds on the flight deck, the Avenger's wings folded back alongside the fuselage. Hydraulic cylinders pulled the wings back in a sweeping compound angle, tucking them neatly against the tail section. This reduced the wingspan from an enormous 54 feet down to a mere 16 feet, allowing the Navy to pack Avengers into carrier hangar bays like sardines. To achieve this, the engineering tolerances on the wing joints had to be absolutely flawless. The wing root locking pins were massive rods of hardened steel, driven into place by hydraulic pressure, ensuring that once the wings were spread, the aircraft was as structurally rigid as if it had been carved from a single block of metal. But accommodating the massive Mark 13 aerial torpedo dictated the entire shape of the fuselage. In earlier aircraft, like the Devastator, torpedoes were slung externally under the belly. This created massive aerodynamic drag, slowing the aircraft down to a crawl and severely limiting its range. Grumman's engineers made the radical decision to place the 2,000-pound torpedo entirely inside the fuselage in an internal bomb bay. This was a luxury usually reserved for massive four-engine heavy bombers, but incorporating it into a single-engine carrier plane required the Avenger to have a deep, barrel-like fuselage. This gave the aircraft its distinctive, pregnant-looking profile, but it smoothed out the airflow over the belly, allowing the Avenger to cruise efficiently over vast distances. However, this internal bomb bay created an immediate, desperate problem for the crew layout. Because the torpedo took up the entire lower half of the center fuselage, the three-man crew had to be stacked in a complex, multi-level arrangement. The pilot sat high up in the front, under a long greenhouse canopy, sitting directly behind the massive twin Cyclone engine. Directly behind the pilot, separated by a bulkhead of armored glass and steel plate, was the turret gunner. The Grumman-designed power turret was an engineering marvel in its own right. A teardrop-shaped glass dome powered by an intricate system of electric motors. It housed a single, lethal 50-caliber machine gun, giving the Avenger a brutal sting against pursuing fighters. But the third crew member, the radio man and bombardier, had the worst seat in the entire naval air arm. He was relegated to a cramped, dark compartment deep in the belly of the aircraft, located directly behind the bomb bay. His job was to operate the complex radio equipment, handle the primitive radar sets that would later be installed, and man a single, flexible 30-caliber machine gun that pointed out the tail, affectionately called the Stinger. During a torpedo run, this crew member had to unbuckle, crawl forward through a tiny tunnel in the dark, and peer through a small window in the belly to help the pilot line up the drop. It was a claustrophobic, terrifying environment, filled with the deafening roar of the radial engine and the overpowering smell of high-octane aviation fuel and hydraulic fluid. But this heavy armor, massive engine, and intricate engineering meant absolutely nothing if the weapon it delivered failed to work. And this introduces the darkest, most frustrating chapter of the Avenger's early combat career. By the time the Avenger was entering mass production in mid-1942, the aviation engineers had done their job flawlessly. They had built a rugged, reliable, survivable delivery system. But the weapon they were delivering, the Navy's standard Mark 13 aerial torpedo, was a catastrophic, unmitigated disaster. The Mark 13 was arguably the worst piece of ordnance deployed by the United States during the entire Second World War. It was a delicate, overly complex, tragically fragile weapon that required absolute perfection to function. To drop the Mark 13 successfully, an Avenger pilot had to fly incredibly low to the water, usually no higher than 50 to 100 feet. He had to fly agonizingly slow, reducing his speed to barely 110 knots. And he had to maintain a perfectly straight, entirely predictable flight path for several miles, ignoring the wall of enemy anti-aircraft fire exploding around him. If the pilot dropped the torpedo too fast, the impact with the water would crush its delicate internal gyroscopes. If he dropped it from too high, the torpedo would snap in half upon hitting the waves. If he dropped it at a slight angle, it would porpoise, skipping across the water like a thrown stone before exploding harmlessly into the sky. The engineering reality was brutal. The Avengers were flying straight into the teeth of Japanese naval anti-aircraft fire, taking devastating losses, enduring horrible damage, all to drop a weapon that simply refused to work. Reports from early Pacific battles were infuriating. Avenger crews would risk everything, fight their way through swarms of Zero fighters, drop their torpedoes perfectly by the book, and then watch in absolute despair as the torpedoes ran entirely off course, sank to the bottom of the ocean, or struck the side of a Japanese carrier with a dull thud, failing to detonate. This technological failure forced an immediate and highly dangerous shift in operational tactics. I want to pause here for a second and ask you all a question. When the weapon your aircraft was specifically built to carry turns out to be useless, do you think the military should pull the aircraft from service or force the crews to improvise entirely new, highly dangerous tactics in the field? Let me know your thoughts down in the comments, because the Navy's solution was brutal. Since the torpedoes were practically useless, fleet commanders ordered Avenger squadrons to completely abandon their primary mission profile. Instead of flying low-level torpedo runs, the heavily armored Avengers were pressed into service as glide bombers. This was a role the aircraft was never designed for. Unlike the dedicated Douglas SBD Dauntless dive bomber, which had massive perforated dive brakes to control its speed and a near-vertical plunge, the Avenger had no dive brakes at all. If an Avenger pilot pushed the nose over into a steep dive, the massive weight of the aircraft would cause its speed to build up so rapidly that the wings would simply rip off from aerodynamic stress. To solve this, pilots had to invent a terrifying maneuver known as the glide attack. They would approach the target at a medium altitude, lower their heavy landing gear to act as improvised air brakes, open the massive bomb bay doors to create maximum aerodynamic drag, and pitch the nose down at a relatively shallow 30-degree angle. The physical toll this took on the pilots was immense. Because the aircraft was flying at an awkward angle with its landing gear dangling in the slipstream, the aerodynamic buffeting was violently intense. The control stick would shake wildly in the pilot's hands, requiring enormous upper body strength just to keep the crosshairs lined up on a maneuvering enemy ship. Furthermore, unlike modern aircraft that feature hydraulically boosted flight controls, the Avenger relied entirely on cables, pulleys, and the raw muscle power of the pilot's arms and legs. Flying a fully loaded Avenger in a tight carrier formation for 4 hours, fighting the massive torque of the right engine, was absolutely exhausting. Pilots frequently returned to the carrier deck soaked in sweat, their arms trembling from the sheer physical exertion of wrestling the 18,000-pound beast through the sky. The gritty reality of operating the machine extended deeply into the crew compartments. While the pilot was sweating in the greenhouse canopy, the turret gunner in the rear was fighting an entirely different battle against the elements. At operational altitudes of 10 to 15,000 feet, the air temperature plummeted well below freezing. The intricate Grumman power turret, while mechanically brilliant, was poorly sealed against the rushing wind. Freezing air would blast through the gaps in the plexiglass, chilling the gunner to the bone. They had to wear thick, electrically heated flight suits just to survive, but the primitive electrical systems in these suits frequently shorted out, leaving the gunner shivering uncontrollably while trying to scan the skies for incoming fighters. Down in the belly, the radio man dealt with the relentless, deafening noise of the exhaust stacks, which exited the engine cowling right in front of his position. Communication between the 3 crew members was vital, but the internal intercom systems were notorious for picking up engine static, reducing urgent tactical callouts to crackling, unintelligible noise. Despite these punishing ergonomics and the early failure of its primary weapon, the Avenger was simply too important to the war effort to fail. As the war in the Pacific ground on, the United States found itself desperately needing more Avengers than Grumman could possibly build. Grumman's production lines on Long Island were already operating at maximum capacity, frantically churning out the legendary F-6F Hellcat fighters that were clearing the skies of Japanese aircraft. To solve this production bottleneck, the United States government orchestrated one of the most remarkable industrial pivots of the 20th century. They turned to the automotive industry. General Motors, specifically its newly formed Eastern Aircraft Division, was contracted to take over the mass production of the Avenger. When the first automotive engineers walked into the Grumman plant to look at the blueprints, they were absolutely horrified. Car manufacturing was based on precision stamping, assembly lines, and high-volume standardized parts. Aircraft manufacturing, especially Grumman's rugged ironwork style, involved thousands of hand-riveted joints, complex aluminum extrusions, and tight tolerance hand fittings. The automotive engineers had to completely relearn how to build machines, transitioning from heavy steel car chassis to lightweight aluminum aircraft stringers. But they learned fast. The Avengers built by General Motors were designated the TBM, replacing the F in TBF, which stood for Grumman. By 1944, General Motors was pumping out TBM Avengers at an astonishing rate, eventually building the vast majority of the nearly 10,000 Avengers produced during the war. While the Pacific theater defined the Avenger's fame, it was in the freezing, brutal waters of the North Atlantic where the aircraft proved its ultimate strategic flexibility. The Allied supply lines to Great Britain were being decimated by German U-boat wolf packs. To combat this, the Navy developed hunter-killer task forces, small, cheaply built escort carriers known as jeep carriers, surrounded by destroyers. The heavily armored long-range Avenger was the absolute perfect aircraft for these tiny flight decks. Equipped with the newly developed ASB surface search radar, with its distinctive Yagi antennas sprouting from the wings like metal whiskers, the Atlantic Avengers became relentless U-boat hunters. The tactical doctrine shifted entirely. Instead of massed fleet attacks, a single Avenger would launch into the freezing Atlantic weather, flying low under the cloud cover, sweeping the ocean surface with its radar. When a German U-boat surfaced at night to recharge its batteries, the radio man in the belly of the Avenger would spot the radar return. The pilot would circle in the darkness, waiting for the perfect moment. They would drop intense, blinding magnesium flares to illuminate the submarine, and then push the heavy Avenger into a screaming dive, strafing the U-boat's flak gunners with the forward-firing 50 caliber machine guns before unleashing depth charges or specialized acoustic homing torpedoes known as FIDO. These Atlantic operations were a maintenance nightmare. The salt spray from the ocean would coat the aircraft, corroding the complex electrical wiring of the power turret and causing the intricate radar vacuum tubes to fail constantly. Mechanics worked on heaving, violently pitching decks, their hands numb from the cold, desperately trying to keep the hydraulic fluid in the Sto-Wing mechanisms from freezing solid. Yet, the robust, simple mechanics of the R2600 engine and the sheer structural thickness of the airframe meant that even in the worst weather conditions on Earth, the Avengers kept flying, eventually breaking the back of the German submarine fleet. Back in the Pacific, the tide had completely turned, and by late 1944, the engineers at the Bureau of Ordnance had finally, mercifully, fixed the catastrophic flaws in the Mark 13 torpedo. They strengthened the internal gyros and fitted the torpedo with a distinctive wooden drag ring on the nose and a wooden box around the tail fins. These simple wooden additions revolutionized the weapon. When dropped from the Avenger, the wooden appendages stabilized the torpedo in the air, slowing its fall, and then shattered harmlessly upon impact with the water, absorbing the kinetic shock. Suddenly, Avenger pilots were no longer forced to fly at a suicidal crawl just above the waves. They could drop the improved Mark 13 from altitudes of up to 800 feet, while flying at a blistering 260 knots. This mechanical fix transformed the Avenger from a frustrated glide bomber back into the lethal naval assassin it was originally designed to be. This lethal capability was brutally demonstrated during the Battle of Leyte Gulf, specifically in the massive airstrikes against the Japanese super battleships Yamato and Musashi. The Musashi was arguably the most heavily armored warship ever constructed, bristling with hundreds of anti-aircraft barrels firing distinctively terrifying, colorful tracer rounds meant to blind and confuse American pilots. The Avenger squadrons executed a flawless, horrifyingly efficient tactical maneuver known as the Anvil attack. They split their formations, approaching the massive battleships simultaneously from both the port and starboard bows. This meant that no matter which way the colossal warship tried to turn to avoid the incoming torpedoes, it was physically impossible to comb the wakes. It would inevitably expose its broadside to one of the attacking groups. Through a literal wall of exploding flak, the TBM Avengers roared in at high speed, dropping their now reliable Mark 13 torpedoes with devastating precision. The Musashi absorbed an incredible amount of punishment, but the repeated, staggering underwater detonations from the Avenger strikes eventually overwhelmed her massive pumps, sending the pride of the Japanese fleet to the bottom of the ocean. It was the absolute vindication of the original 1939 design specification. The heavy, unglamorous flying truck had delivered the fatal blows to the most advanced battleships on Earth. As the Second World War drew to a close, the era of the torpedo bomber rapidly faded. The advent of jet aircraft and advanced anti-ship missiles rendered the slow, low-level torpedo run obsolete. But the Avenger, true to its stubborn nature, simply refused to retire. Its massive internal bomb bay and cavernous fuselage, originally designed to house a troublesome weapon, made it incredibly adaptable. In the post-war years, the Navy stripped out the turrets and torpedo gear, filling the belly with massive radar consoles, turning the Avenger into one of the world's first airborne early warning aircraft. With a massive bulbous radome bolted to its belly, These modified Avengers flew high above the fleet, acting as flying radar stations, protecting task forces from surprise attacks well into the 1950s. Other nations quickly bought up surplus Avengers. The Royal Canadian Navy and the British Fleet Air Arm used them extensively for anti-submarine patrols, highly valuing their long loiter times and rugged reliability over freezing northern waters. Even when the military finally retired the type, the civilian sector found a use for the unstoppable airframe. Stripped of their armor and military hardware, Avengers were fitted with massive internal water tanks and flown for decades as aerial firefighters, diving low through blazing canyons to drop fire retardant on forest fires, a mission profile shockingly similar to their original dangerous combat runs. The legacy of the Grumman TBF and TBM Avenger is utterly unique in the history of military aviation. It was never beloved for its grace, its speed, or its comfort. It was a machine born out of a desperate strategic necessity, forced to overcome the catastrophic failure of its own primary weapon, and reliant on the sheer brute force of American automotive manufacturing to reach the front lines in sufficient numbers. It froze its gunners, exhausted its pilots, and deafened its radio men. But when the skies were filled with flak, when half the control surfaces were shot away, and when the mission demanded flying 300 miles over open ocean to deliver a fatal blow, the Avenger brought its crews home. Thank you so much for reading this deep dive into the gritty reality of the Grumman Avenger. If you want to see more content breaking down the engineering compromises and operational truths of historical aircraft, please hit that like button, subscribe, and let me know in the comments which aircraft we should put under the microscope next.